Welcome to the deep dive. So you've handed us what looks like a data sheet for a very specific piece of gear. It's called the Thor Broadcast H-16ATSC-IP.
It does look a bit intimidating.
It does. But our mission today is to decode what this black box actually does and maybe figure out why this RF to IP modulator is, well, kind of a silent hero in video distribution.
It really is. I'd call it the nerve center of a modern media head-end. This one little box is just one rack unit high, basically bridges the gap between old school broadcast and, modern IP networks.
Okay, let's start with the inputs then, because the numbers here are frankly wild. It says 16 independent RF tuner inputs. So it can listen to 16 different broadcast signals all at once, like ATSC, QAM for cable, even satellite.
Exactly. It's a true broadcast omnivore. But the real magic is its core job, taking those traditional RF signals and converting them into internet protocol streams instantly.
And it creates a lot of them. I'm seeing 512 IP SPTS outputs.
Right, 512.
What is an SPTS? A single program transport stream.
Right.
Why so many?
Yeah, and the single program part is key. It means every single TV channel gets its own individual routable stream. Think of it less like one giant water pipe and more like 512 separate labeled water bottles.
Okay, so you can send each channel exactly where you want it to go on the network.
Precisely. Using standard protocols, UDP or RTP, it gives you this incredible flexibility that older, rigid systems just couldn't dream of.
And it's not just those 16 tuners. It looks like you can also bring in 512 IP streams from another source or use these two ASI inputs. It's a real hub.
It is. And that mixing capability leads to its other big role, being a transmodulator. A cherry picker, as the industry calls it.
The cherry picker.
It's not just translating signals, it's actively rearranging them. It can grab, say, up to 8 RF frequencies from the air, convert them to IP.
Okay.
And at the same time, it can create 8 brand new RF channels from those same sources. It's rearranging the whole channel neighborhood on the fly.
And I see a perfect example of that here. Dave's way of taking an ATSC broadcast signal and converting it into both IP streams and a QAM cable lineup.
Exactly. That's a huge deal for the ATSC 3.0 transition right now.
So it lets a cable company keep their existing hardware, but still integrate the new broadcast standards.
You've got it. It's a software solution to a hardware problem. But all that juggling, all that converting and rearranging, it has to be perfect.
Right. The quality has to hold up.
Which is why the spec points out a modulation error ratio, or MER, of at least 40 decibels.
And for those of us who aren't RF engineers, why is that 40 dB number so important? What does that mean for the picture on my TV?
40 decibels is a very, very high bar. It means the signal it outputs is incredibly clean, almost no noise or distortion. After all that processing, maintaining that purity, well, it's a serious engineering feat.
Okay, so that handles the signal quality, but there's this invisible software layer too, right?
Yeah.
I'm seeing things like accurate PCR adjusting.
Yes.
If that failed, what would I, the viewer, actually see?
Oh, you'd see it immediately. The audio would slip out of sync with the video. PCR is the program clock reference. It's the heartbeat that keeps everything locked together.
The worst.
Yeah.
Okay, and what about PSAI editing?
That's all the metadata. That's the stuff that tells your TV guide what channel you're on and what show is playing. Without it, your receiver would have no idea how to organize the channels. It wouldn't even be able to build the guide.
So it's basically the digital signpost for every single stream.
A perfect analogy. And it's all managed through a simple web interface.
So bringing it all together, what's the big picture here?
I mean, this one box lets a facility get incredibly dynamic. You can add free over-the-air channels to your cable lineup, build a massive RF to IP gateway, and basically future-proof your entire operation. It replaces entire racks of older single-purpose gear.
That agility is really the key. So, and this is the thought I want to leave everyone with. If the single one-rack unit device can juggle 16 sources and pump out 512 IP streams, how many of these do you think it takes to power an entire major city's network? And what happens when a system this powerful moves completely to the cloud? That's something to think about.